Hello and welcome to online lecture number 8 for Chemistry 1101 during the spring semester of 2020. In this lesson, we'll continue in chapter 9, and this will be the first of 2 lessons where we focus on a very important unit of concentration called molarity. In the previous lesson, we looked at percent concentration, and we defined percent concentration in various ways, where the difference was how we express the amount of the solute and in what unit do we express the amount of the solution. Molarity is still that same idea, the same ratio of amount of solute to the amount of solution, but molarity specifically is defined as the number of moles of solute, which is how we typically describe the amount of a substance, and then the volume of solution will be described in units of liters. And so molarity, abbreviated capital M, is simply the ratio of the number of moles of solute to the liters of solution. Ratio of the amount of solute to the amount of solution. And what's nice about molarity is that not only is the most commonly utilized concentration unit for chemicals, so if you walk into a chemical laboratory, it's very likely that most of the bottles, for example, will be labeled with the concentration in units of molarity rather than percent concentration or some other unit. But also what's nice about molarity is that unlike percent concentration, you can actually directly compare concentrations of different solutions. So in the previous lesson, we looked at, I think, a 3% hydrogen peroxide solution and a 3% table sugar sucrose solution. And even though they're both labeled and both have the same percent concentration, they had different numbers of those respective molecules per liter. But that's not true with molarity. With molarity, if they have the same molarity, in this case 1.00 molar hydrogen peroxide solution or a 1.00 molar sucrose solution, by definition, they have the same number of those molecules per liter. So a 1.00 molar hydrogen peroxide solution means that the solution is composed of 1 mole of hydrogen peroxide per liter of hydrogen peroxide solution. Likewise, a 1.00 molar sucrose solution, C12H22O11, by definition, is composed of 1.00 moles of the substance, sucrose, per liter of the solution. And because we mean by mole is Avogadro's number, that means that both these solutions with identical molar concentrations are composed of the same number of the respective molecules per liter. In this case, simply 6.022 times 10 to the 23rd hydrogen peroxide molecules per liter for the 1 molar hydrogen peroxide, or 6.022 times 10 to the 23rd sucrose molecules per liter for the 1 molar sucrose solution. So for those reasons, as well as the fact that we express the amount of the solute using moles, and as we said, is the way we commonly describe the amounts of substances, makes it a very convenient unit to describe the concentration of a solution, and therefore is the reason why it's the most commonly utilized concentration unit. So this will be the first of 2 lessons on molarity. And this first lesson, we're just going to focus on the definition of molarity. In other words, given how a solution is prepared, how can we calculate the molarity of that solution? And so we'll just spend our time doing a couple examples of those types of calculations. In the first question, we have 5.67 moles of sodium chloride solute was dissolved in enough water for a total volume of solution of 1.24 liters, and we're asked to calculate the molarity of the solution. Okay, so we have our picture, 5.67 moles of sodium chloride dissolved in a total volume of 1.24 liters. To calculate molarity, all we need to know is the number of moles of solute and the liters of solution. And in this first example, these examples will get a little bit harder as we go along. We're given both those numbers directly. 5.67 is the number of moles of solute, and 1.24 is the liters of solution. So the molarity of solution will then be the ratio of 5.67 and the 1.24. So we plug in our calculator, 5.67 moles of sodium chloride per 1.24 liters of solution, just a ratio of the moles of solute per liter solution. And we plug into a calculator, 5.67 divided by 1.24 gives us a molarity of 4.57 M for molarity sodium chloride. So if the solution was prepared this way by dissolving this amount of sodium chloride in this total volume of solution, then we could properly label it as a 4.57 molar sodium chloride solution. In this next example, we have 1.03 moles of methanol dissolved in 845 milliliter solution with the same idea that we want to calculate the molarity of that particular solution. So we have a 1.03 moles of the solute, methanol, CH3OH, an alcohol, dissolved in a total volume of 845 milliliter solution. So once again, to calculate molarity, which is what we're asked for, we want to find the number of moles of solute and the solution, and that ratio is our molarity. So we have moles of solute, that's the 1.03 number. But we're given a volume of solution, but it's not in the correct units. So just like the ideal gas law calculations, just like any other calculation, before just blindly plugging our numbers, we want to make sure the units are what they're supposed to be. And the units have to be liters. We're given, though, the units in milliliters. So the first thing we want to do is convert our volume in milliliters, rather, into liters. So we can do that, as we've done before, by dividing by 1,000. So 1,000 milliliters in 1 liter. So a volume of 845 milliliters, so what we're given, is equivalent to a volume of 0.845 liters. So that's the volume in liters of the solution. So therefore, that's the number we put into the denominator of our equation. So divide by 0.845 liters. And you plug this number into our calculator, 1.03 divided by 0.845 gives us a molarity of 1.22. So 1.22 molar methanol is how we would label this solution. That will be the molarity of that solution prepared by dissolving 1.03 moles of the substance in a total volume of 845 milliliters. So two quick examples of, given how the solution is prepared, how we can calculate the molarity of that solution. We'll do two more examples, and then that'll be, I think, enough for today's lesson. In this next one, we have a solution prepared by dissolving 36.2 grams of lithium hydroxide in enough water for a total volume of 2.85 liters. And ask once again to calculate the molarity of the solution based upon the description of how it was prepared. So our picture is 36.2 grams of lithium hydroxide dissolved in enough water rather, for a total volume of 2.85 liters. So to find the molarity, we need to know the number of moles of solute and the liters of solution. We know the liters of solution is 2.85, so we already know in our molarity calculation, we already know because we're given the denominator, 2.85 liters of solution. We need to find the numerator. We need to find moles of solute. We're not given moles of solute, but rather we're given grams of solute, grams of lithium hydroxide. So like in the previous example where to answer our question, we had to do one earlier calculation, we need to do the same thing here. Before, we had to convert our milliliters to liters. We have liters. In this case, we need to convert our grams into moles. And so our plan, our strategy here is to convert our grams of lithium hydroxide, or we're given 36.2, into moles of lithium hydroxide, because mole units is what I need for my molarity calculation. So convert from grams to moles. As always, that's going to be the molar mass of the substance. So we have 36.2 grams of lithium hydroxide. We divide by the molar mass. 1 mole of lithium hydroxide is equal to the mass of 1 lithium plus 1 oxygen plus 1 hydrogen. So we have lithium at 6.94 plus 1 oxygen is 16.00 plus 1 hydrogen is 1.008 for a molar mass of 23.948 grams. So as always, convert from grams to moles, we divide by the molar mass. So in other words, then 36.2 grams of lithium hydroxide is equivalent to about 1.008 0.512 moles of lithium hydroxide. So now we have the amount of lithium hydroxide in the correct units, moles. That's going to be the number I plug into my numerator or use as my numerator. So 1.512 moles of lithium hydroxide. So therefore, the molarity is just that ratio of 1.512 divided by 2.85 gives me a molarity of about 0.531 molar lithium hydroxide. So in this case, to find molarity, we had to first convert our given amount of solute in grams. We had to convert that into correct units of moles. And as always, we can do that by dividing the mass of the substance by its molar mass. And then we'll finish up with the most complicated of these types of calculations, at least the most complicated as we'll see for our class, where we're given a description of how a solution is prepared by dissolving 22.0 grams of a substance, this is ethanol, dissolved in a total volume of 395 milliliters of solution. And the question, once again, is always to calculate the molarity of that particular solution based upon how it was prepared. This is our picture, 22 grams of ethanol dissolved in a total volume of 395 milliliters. So as always, to find the molarity, we need to know two things. We need to know the moles of solute, and we need to know the liter solution. And in all the other examples, we knew we were given directly at least one, if not both, of those two numbers directly. Here, we're not given either one directly. We're given the grams of solute. We need moles of solute. We're given milliliters of solution. We need liters of solution. But we know how to do those conversions. So to convert first our volume, we're given a volume of 395 milliliters. So as we did on our second example today, we can divide by 1,000 to convert our volume in milliliters to a volume in liters. So 0.395 liters, just a unit conversion, is the exact same meaning as 395 milliliters, but 0.395 liters is more relevant because that's the unit we need, liters, for our molarity calculation. So that's going to be my denominator, 0.395 liters of solution. And then the numerator then becomes the moles of ethanol. So we're given grams. So like we did in the previous example, we want to go from grams of the substance to the moles of substance. And as we did before, as we do always, to convert from grams to moles, we're going to use the molar mass information of whatever that substance is. So in this case, we have 22 grams of our C2H5OH. We then want to divide by the molar mass of that same substance. So 1 mole of ethanol has a mass of 2 times the mass of carbon, 2 times 12.01, plus 6 times the mass of hydrogen, plus 1 times the mass of oxygen, for a total of 46.068 grams. So mass divided by molar mass will give me the equivalent number in moles. So 22 divided by 46.068 gives me a number, 0.4776 moles of ethanol. So this number in moles has exactly the same meaning as this number in grams, but this number is better in a sense because it's in the right units, correct units. So that's my numerator, 0.4776 moles of ethanol. And then finally, the molarity calculation is just that ratio, moles divided by liters. So 0.4776 divided by 0.395 gives me a molarity of about 1.21 molar ethanol. So in all these examples, we were given how the solution was prepared, how many grams or moles of solute were present, and what the milliliters or liters of solution volume was. And they were asked in each case to calculate the molarity. So to calculate the molarity, we need to know moles and liters, And so we have to take the information given to us directly, or the most difficult type of problems, use the information given to us to first convert to the appropriate units, and then plug those appropriate units with the appropriate numbers into our molarity equation, moles of solute per liter solution, to find the molarity of the solution, 1.21 molar C2H5OH. So this is going to be one type of calculation that we'll encounter using molarity. The next type, in a lot of ways the more important type, we'll talk about in the next lesson, which are examples where we're given the molarity of the solution. Because if we're given molarity of the solution, that's going to allow us to, if we need to, relate or convert moles of solute to liters of solution. Because the molarity is, by definition, that ratio of moles of solute to liters of solution. So if we know that number, we can then use that as part of a conversion factor, as part of one calculation or a series of calculations to relate the amount of solute to the volume of solution. That's what we'll get to in our next lesson.